Okay everyone, hello. Excuse me. Okay, let me fix up these slides a little bit. Okay, I think that should say lecture 8, but welcome. Sorry I was a bit late. My UNSW password decided to reset like an hour ago, so everything got logged out and all of that stuff. Actually, it's only 2 minutes late, that's not too bad. Okay, welcome back everyone to, it should be lecture 8, but week 4 lecture 2. Again, if you weren't here for yesterday's lecture, or you haven't seen it yet, I'm a little unwell, so apologies for my voice and if I'm a bit slow today and all of that, but I'm feeling a bit better, so that's good. Okay, everything looks in order. Today we're talking about 2D arrays, so sort of a bit of a departure from what we were talking about yesterday, but we might even have some time to recap some of yesterday's content as well. And I was reading some of the chat. Can we do a bit of a recap on 1D arrays? We absolutely will as the first part of the lecture, which is good. So the 1D and 2D arrays are going to be really important for assignment 1. And some of the content we covered yesterday is more important for later topics in the course. Betsy says, I couldn't access the final lecture code about pointers from yesterday. Could you try now? I think it should work. Have you tried like in the last 5 minutes? 3D arrays when? Well, it's entirely possible. So you could play around with that. Okay, let's get straight into it because time flies. I'll have a look later, Betsy. Sorry about that. Okay, 2D arrays. So what are we talking about here? Okay, we don't need to go over a recap of this. You've already got the link to the lecture code. That's all good. We've released assignment 1. I'm sure you've all had a look at it and probably already started it. It's really important. The assignment focuses on arrays and two-dimensional arrays to solve problems. All of the code that you'll be writing now for the rest of the course and for the rest of your programming career, it's important to have good style and good coding quality. So that's going to be looked at with this assignment. Use functions in your code. It's sort of all the things we've covered from last week's and earlier's lecture, and as well as some of the content today will help you in assignment 1. So you'll practice your skills in debugging code, using 2D arrays and doing all of that. So there'll be an assignment 1 live stream. We didn't do this for assignment 0, so this is something new. So yeah, it should be released. We'll get some of the tutors that helped write the assignment to come onto a live stream and just sort of walk you through the spec and talk about, did the slide say it was released today? No, it's just been released. Oh, released today. Yeah, okay, ignore that. Ignore that, sorry. Yeah, it was already released. What was I saying? Yeah, so we'll announce the details of the live stream. I think we'll do it later this week. And we'll get, I think, whoever can make it to talk about some of the content that'll be covered in the assignment, how to read through the spec, and it'll be a live stream, right? So you can ask questions and get clarifications. So take your time between now and the details of the live stream to read through the spec and build up all of your questions. Then you can ask them and get them answered in real time. Cool? Just like last assignment, there will be stages to the assignment, right? So you should maybe be able to get started with the first stage, and some of this stuff will help with the future stages. Yeah, your slides, I think, are a bit out of date, Elizabeth. So it's not, it's hotel, yeah. Okay. So before we get started with two-dimensional arrays, let's talk about one-dimensional arrays. What are they? They are a collection of elements all of the same type. You need to know the type of the element you want to store, the name of that variable, and how many of those elements that you want to store. Arrays are randomly accessed or randomly accessible. So you can, I would access the first element or the fifth element just by using an index, which is pretty cool. Indexing starts at 0 and moves through until the final element. And loops work really nicely when you want to access each sequential element in an array, because you can set I to 0 and increment it each time the loop increments so that you can access each element in the array, go through one by one. Are there any questions on... Oh, here's some more stuff on 1D arrays. So in this example, we declare an array of integers and we initialize the 7 values using this sort of syntax here. Remember, you can only do this if it's on the one line and you know all the elements that you want to store. But what's more common often is that we create an array and we might need to load the values in from scanf or something like that. And you can picture this as a row of elements in a container. The index at the bottom, 0, 1, 2, 3, 4, 5, 6, and then the value inside the array. So this array is holding 7 integers. So if I did ice cream consume bracket 2, for example, that will get me the value 1. So Nicholas says, when you say this, an array needs to contain elements of the same type, what exactly are we talking about here? Well, in this case, all 7 elements in this array have to be integers, right? So we literally mean the type. So you can have an array of characters, you can have an array of doubles, whatever the data type that you want to store is, but they must all be integers. Which in this case, you can see that they are 3, 2, 1, 2, 1, 3, 5. Nicole, you can picture this as rooms in a hotel floor. Yeah, so you can absolutely have an array of enums, you can have an array of structs, you can have an array of almost anything as long as it's the same data type each time. AR11 says, what about mixed types? That's getting a little bit ahead. It is and it isn't possible. Sort of theoretically, it's not possible. You always have elements of the same types in your array. However, practically, we can make it so that what we actually store, if you think back to yesterday's lecture, you could consider that what if you store a pointer in the arrays, right? And the pointer can point to some arbitrary data. In that case, you could sort of build up an array that contains differently sized elements, but in real terms, it's still only containing a pointer in each element. Does that make sense? But this is getting a bit out of scope. This is how, for example, in Python, so Python can put different types in an array. That's how it's doing it. It's always just storing a pointer to an object. The object can have other things. And you can, yes, Anthony, you can put enum values in an array, no problem. Remember, enums are just integers under the hood, so they can just go in, no problem. Yeah, in fact, the array of pointers thing we will sort of do later in this course with the linked lists. Sort of. But yeah, that's typically how you do it. But you need to have some structure around it, because you need to know what big the thing that you're pointing to in the array is, or how big it is. But anyway, but still, it is still true that even if you are doing that, right, you've still got the one type in each element. So if we just keep it simple, in this case, you have to say, I want an array of integers, therefore each element in my array is an integer. Okay? So like we said, we can access any element in the array. So for example, it gets cut off. So in this example, if we use the name of the array and then the index value of 2, what value are we going to read? Well, it's going to look up this index and access this value, value 1. So this is what the random access means. We can randomly access any element in the array as long as we know the index of the element that we want to access. Okay? Any questions with this so far? Why is it random? Do you mean why is it called random access? So think of it this way, why is RAM called random access memory? It's called random access memory, and an array is a randomly accessible data structure because you don't need to, some data structures, like a linked list that we'll talk about later in the term, you need to access, so if you want to access the 4th index, for example, in a non-randomly accessed structure, you would need to start at the first one, then visit the second one, then the third one, then the 4th one, then you would finally get to the index 4 element that you were hoping to access. However, in a randomly accessed data structure, you can just, if you know the index, right, you don't need to do that, you can just go straight and ping this element and get the value 1. So that's all the random means. It's not random in that we're not controlling it. It's just that we can arbitrarily decide where in the array we want to access. So like we said, like in this example down here, I know it keeps getting cut off a bit. I can't really fix it actually. But in this example down here, we can just access this index of 2. So it's random in that we can just randomly go in and take it out. We don't need to iterate through the array or anything like that. Exactly right. You can skip to a point to do the access rather than having to do some structured, non-random linear access. The name is I get where the confusion's coming from, because the name random sort of indicates that it's out of our control. It's random. We're not controlling it, but we're still controlling it. It just means that we can go in at any point. Not like BOGO sort. Yeah, exactly. Okay. So if you remember, do you want to do a quick demo with 1D arrays again? I think we did this exact function last, when we covered single dimensional arrays. We did the minimum, right? Do we want to do that again? Go through it again? Or do we want to keep going to do 2D arrays? Let me do a poll. I know you all love polls. What should we do? 1D array min recap 2D arrays. It looks like 1D array is going to win it out, but it's always good to be democratic. Regardless, let me get set up while you do that, because we'll be doing some code writing today. Public HTML, CD COMP1511, CD lecture code, CD week 4. Okay, let's go gedit. I think it's going to be, 1D array.c ampersand. Finally a balanced poll. I agree. Whoops. Okay. This would be a really good time to follow along. I'll go a bit slower. So I recommend, I'll give you all a minute to sort of get set up and follow along some coding with me. So it's going to be a pretty small example of a 1D array program. So get your editors open. I'm going to get started here as well. Int main void return 0. Thank you, gedit. I'll save that. And that should be available to you on the course website if you just want to access this. Okay, if you're on the train, that's obviously different. Yeah, I don't know why the polls don't add up to 100%. I don't know what it is. Someone figure it out. Okay. So first thing first, we need to decide, well, first of all, let's write a program to calculate some stats from an array. Jake Renzella 22T2. We can do that, so it's not just minimum. We can do some different stats. Okay. So first of all, we want to know the size of the array. Okay, we can do a hash define here, array size, and we can just say 10 elements. 10 elements. Okay. Then we need to make our array. We need to decide what data type we're storing. So we could source an array of integers, or we could store an array of doubles. Nothing else would really make sense here. It's up to you what you want to do. Why don't we do double? Because we're going to be doing some minimum, and maybe we'll do some averages, and doubles make a bit more sense. sense for that. And then we need to say the size of the array. The array size is going to be the array size. That's going to be replaced with 10 when the program is pre-compiled. And we don't want to initialize it at this point because we want to scan in the data from the user. Actually, so maybe we won't make it 10. Maybe we'll make it 5. So we're not sitting here entering values in for too long. So this is not a variable length array, but I can understand why you might think it is. This is a static length array because this 5 replaces array size before the program is executed. Yeah, because it's a constant. Exactly right. Yep, good catch though. So you got to remember, hash defines replace the name with the value in the pre-compile. So it happens very early. So this is literally as if it's being done like this. But yeah. It's not a global variable though. It's a search and replace. Whoops, yeah. Okay, all right. Now the first thing we need to do is initialize the data from the user input. So we want to scan in data into the array. So we need a while loop. First of all, we need to say int I is equal to 0. What's Bonrick saying? Wait, really? And we can say while I is less than the array size. Oh, yeah. Yeah, so hash defines are pretty weird in C. Let me find a nice article that I'll link for you. It's not a nice article. Okay, that's way too complicated. Here you go. You can read about the preprocessor here. Master Googler, exactly. Okay, but let's not get too off track. All right, so whenever we want to loop through an array and do something to every element in the array, well, we need a loop. We want to increment I by 1. This is what I forgot to do yesterday. I equals I plus 1. Remember, you could always do I plus plus as a shorthand. These two statements are completely equivalent. Yeah, we could do structs and arrays at some point as well. But let's just keep this really simple. Now, what do we want to do every time we loop? Well, we want to access my data, right? And if we're accessing an array at an element, we need to give it the index. We could give it a number, but then it would always be the same number. What we want to do is give it our variable I, because our I will start at 0 and increment by 1 every time the loop executes, only while that index variable is less than the maximum array size. If it's at the maximum array size, then we have gone over too many elements. We won't want to run anything. Now, so this now represents the data at that element position. What do we want to do? We want to scan F. We're scanning in a double, sort of a percent long float, comma, into my data at that position. Sorry, I'll slow down if I type a bit too fast. I'll slow down. Now, remember, with arrays, we don't need to put the ampersand. Is that right? I think that's right. I mean, Oh, you still have to? I might have misremembered. Oh no, you do. Okay, you do. You do. Apologies. You don't need to if it's the whole array. Okay. Yep. Yep. Okay, cool. Clear. Okay, good catch, everyone. Suspicious, yeah. All right, so we scan in a floating point into that particular element looked at by array at that index. All right, and then we increment the array. Okay, what are we missing here? Well, it's not technically missing, but what would be nice to have here? Yeah, printf, exactly right. Let's let the user know that they should enter in the, and we can even do %d value, and then we can give it I. All right, let's compile this. It's good to compile early and often. Okay, DCC 1D array -o to program. Make sure we've got no errors. We don't. Oh, yeah, you're right. I don't want to put a new line, but I'll put a space. I'll put a space after it. All right, let's run this. Enter in the 0th value. That's fine. All right, you're being particular. We can do I +1 here. Oh, okay. I'll keep it at I1 T. Anyway, you get the idea. Enter the first value. We can do it 50.5, 12, 41, 161.4.5, whatever. And then we get our, it looks like so far everything's working okay. Our 5 values are being read in the loop. And then that's sort of all we're doing with it. All right, what if we want to, now what do we mean by random access, right? So arrays are randomly accessible. So we can do printf %long float in strings. My data at index 2, and that should print out, I'm gonna have to put all the data in now, again. Right, and that prints out the value 3. So this is just to show that our data is randomly accessible. Okay. Now the whole point of this was to come up with some statistics, like finding the minimum. Excuse me, so we can find the, why don't we first just find like the sum. We can copy this. Oh, not an int. The sum can equal 0 there. And then we can simply do sum is plus equal to my data at I, not forgetting to go I plus plus, and then we can just go printf the sum is And then don't forget to give it the sum. The terminal is off screen. Is that better? Okay, are we all keeping up? Am I going a bit too fast or too slow? Oh yeah, long float. Thank you. No, it's good. And how about, right, instead of... How do you block comment in? Don't worry about it. Okay. What does the plus equal to stand for? Good question. Excuse me. So plus equal to is just take what's on the left, add the thing on the right back to it. So Anthony says, does computing the sum in the first while loop instead make the program more efficient? Excuse me. Yeah, I see what you're saying. We could just keep track of the sum up here, but we're just sort of separating out the input from these sort of operations. Now, what might be nice to do is we could make a function to do this that accepts an array of the array size right, so that we put our things in functions. We say that int I there, double sum is there, and then we just want to return double. Right, and then we could say calculate that sum of my data there we go. Whoop. Let's see, line 13. I just called it array here, not my data. Looks like I'm forgetting a semicolon here as well. Oh, and that should be the sum, not double, with the semicolon. Okay, nice. And we can run this program. And again, if I just spam in 1, 2, 3, 4, 5, we should get all of that working nicely. Cool. Okay, I think we did minimum in the last lecture. Do we want to do one more quick example, or do you sort of... The point here is just that we can read data into an array and print data out, access it sort of randomly, and do some calculations with the array. Can I explain the function bit again? Sure. So, you know, we were calculating the sum just here in main, but if it's something where we might have like a... So for example, right, I could have a second array And I could assign it, 1, 2, 3, 4, 5, right? By moving this functionality into a function, I can then, for example, calculate the sum really easily over multiple arrays without sort of rewriting any code. And in fact, I could just print this out here. Okay, like always, I'm forgetting my semicolons. Nice. And then we get, we can reuse that sum function over multiple arrays really easily to keep using it. Anthony says, can you chuck an array that's not an array size into the function? No, not in this case, because I'm telling it explicitly I want to accept an array of size 5. It might still work though, but it might break when it actually tries to use it. Okay, are we happy with this recap? Could I explain line 9 again? Okay, no problem. Good idea. This is a function that returns, let me see here. So Justin, what data type does this function return? No one else answer? Okay, bad luck, Dorian. Yeah, exactly right. So it returns a double. Why? Because we're going to be calculating a sum of data into an array. That's fine. You're fine, Dorian. What's the name of the function? And what parameter is it accepting? I mean, maybe not just Justin has to answer, but I think we're starting to get the idea, right? If we break it down, okay, there we go, Justin. Calculate sum, that's exactly right. Well done. It's called calculate sum. Why did we call it calculate sum? Because the function is going to calculate the sum of an array of doubles. So it's just what we're going to name it. And what data does it accept? Now, I'm guessing this is the part that's confusing people. So what data does this function accept? Well, this function is going to accept an array of doubles. So a double array. Well, I'm calling it array in this case. But this could be my data, for example. So it's an array of doubles with the size in the square brackets. It's just like we're declaring an array down here, right? Can you see that's exactly the same? Well, let me use this one. This here is exactly the same as this. When we have parameters, right, when we put these in brackets, we're literally just saying, I want to make a variable that is the input into the function. But in this case, I did rename it to my array. Maybe my data's a nicer name. Matthew says, if you had the parameter as my data, then it would only calculate the sum of my data and not my second data, right? No, that's not correct, Matthew. So, it doesn't like, let me just call this like input array. It doesn't matter what this is named. So we pass in an array, whether it be my data or my second data. It gets passed in, but the name, it doesn't really care what the name is. It's going to make a new array called input array in this case now. Yeah, it gets substituted in. That's exactly right. That's exactly right. Yeah, all good, Joe. I hope you survived your bird attack. So it's just, what it's saying is, what is the data type that I should be accepting as a parameter? And what am I going to name it? So that I can refer to it in the function. What happens if you change double to int for the calculate sum function, parameter, or the array my data? If we make these arrays store integers, most of it would work, but then keep in mind when we're doing the printf and the scanf, we're telling it here that they're doubles, not integers, right? So it would break potentially at this point or something like that. So Justin says, could you explain how return sum in the function and double sum equals my data are related? Okay, so basically, right, even though this double is called sum in this function and this double is called sum in main, they're completely unrelated. They're different variables, right? So remember we spoke yesterday about stack frames in the memory? So this function is operating in a different stack frame. So it has its own area of memory for its integers, its variables that are created in the function. So all this is doing is saying create a double named sum that's made within main, and assign it the result of calling calculate sum. So these just happen to have the same name. They don't need to. Right, I could call this array sum. Right, now it has a different name and it's going to work all the same. Never mind. If I rename it everywhere. See? Valerie says, are we allowed to pass arrays as pointers? Yeah, you can do that. I think they're pretty close to being similar. However, with this, you pass in the array size. So if it's a static array, I think it's better to do it like this. If it's a truly dynamic array, you can pass it in as a pointer, I think. Windows says, how does the function know that input array, well, let's say, how does the function know, let's say, input array bracket 1 is? Could you rephrase that, Windows? And Nickel said earlier, where is the second sum coming from? The first one's coming here, and then we print it out here. The second one, I'm just calculating and printing straight away here, without assigning it to a variable. And then I think I also saw someone asked, is calculate sum like a procedure? Remember, functions return stuff, so they have a double out here. Some functions don't return anything, they return void. We call those procedures sometimes. Okay. How does it know what value input array of I has? Well, remember the data, the entire array is passed in when calculate sum is called. So for example here, my data is passed in. My data is the array with all of the elements scanned in. So all of the data gets passed in. So it's in there. It's just in there. It can read it. Yeah, so that's exactly right. So the my data array gets passed into the function, and now it maps it over to this input array, and we have access to this input array variable. But I think the key is not to get confused by the names, right? Because you can see I've called it a second time here with a different variable as the array, my second data. So you can see that it doesn't make sense to match the names of the variables. What makes sense is that as long as I'm passing it in an array of data, then I'm happy. An array of doubles explicitly. Unrelated question, how do side effects happen when the stack frame disappears at the function procedure resolution? What do you mean by that? How do side effects happen? I guess the answer would be that the side effects happened before the stack frame dissolved. Window. So a function is like a formula that you can keep subbing values in 100,000%. That's exactly right. I mean, the idea of a function comes from mathematics, like f of x. We don't know what x will be. We don't know what input array will be. It will just be substituted in when it's called. In fact, how does a procedure affect the main program at all without using memory? Without using the heap memory. Well, keep in mind, like a side effect could be that you printed some text to the terminal. That doesn't really affect the main function, but it affects the program. Does that make sense? It's a side effect to the program, not to main. So when we say side effect, it doesn't necessarily mean to the memory. It's just to the overall program. Okay. Any final questions on this program so far? If you weren't able to keep up and writing it with me, maybe it'll be a good exercise for you to type this out and try and understand it. Okay. Joe, so functions only return one value? Yes, that's pretty much correct. Okay. We can also have an array of structs. Someone was asking about this earlier. So if you make a struct, you can store an array of that struct. And then that struct, each element in your array will contain a struct of that type. And then you can use, just like you use with structs, you can use the period to access members of that struct. We could do a super quick example of this. I'm conscious of time though. Gedit that's all good. Struct array dot C ampersand. Okay, I'm gonna don't feel the need to follow me here because I'm gonna go a bit faster, just because I'm a bit short on time. Return 0. Okay, we need to make a struct. We can call it position. Has an X and a Y. Okay. We also want a hash define. We can put 5 elements in the array. Okay. We're making a struct array. We'll call it positions. Okay. Oh, no, sorry. Struct position. We'll call it positions with max elements as the capacity of that array. Then we can pretty simply go int I equals 0. Now we haven't started to the arrays just yet. While I is less than max elements. Okay. Oops. Positions of I is going to be equal to dot x can be equal to I. Positions I dot y is going to be equal to I as well. That's fine. Okay, and then we can just do the exact same thing after, just to prove that it all works, but we can just print these are integers, so %d thank you. Okay. And this will be y here, and this will be y here. Now in this example, no, I'm not scanning anything in. I'm just going to actually assign x to be I. So it'll start at 0 and then go to 1, 2, 3, 4, for example. Whoops. That can't be an int. All right, how's this going to look? Okay, we call this struct array instead. Oh, no errors. Pog. Cool. Why don't we do a printf new line at the end of every loop, just to get that nice and clear. There you go. So this is literally storing an array of structs, an array of position structs. We loop through, we're just assigning them whatever the value of I is, and then we can loop through and print out the positions with some formatting so that we can see the values in there. But there could be more to this. We could put doubles in here, we could put characters in here, whatever it is, whatever's in this struct, we get an array where each element is the struct. Cool? Any questions on this? I know it's a very simple example, but it does the job, I think. How would we work with this if it was needed to use scanf? Pretty simply, right? You could just do scanf percent. It's an integer, right? Just something like that would do the job, right? But what's important is that you can't scanf straight into the struct. You access the element in the struct that you want to scanf into. Okay? Just wait till we've got arrays and arrays of structs. Can we scanf into two different elements of the struct in one line? Yeah, I believe we can. So I think all we do is we would go like this, %d, %d, this. We can give it a go. Something like this. Enter the x and y. Okay, I can do, these are integers, right? So 5 and then 4, 4 and then 5, 1 and then 1, 1 and then 3, 5, 6 and then 1. And then you can see that's all gone in just perfectly. Cool. Nice. Okay. Let's have the mid-lecture break. Once again, I apologize, no Kahoot this week, but there was a Kahoot in the tutorial. You'll all live. We'll do a mid-lecture break, 5 to 10 minutes. I'm going to top up my tea and all that stuff. Yeah, apologies about the Kahoot. Or maybe I'll try and make one quickly in the break. Okay, yeah, what's going on? So we don't have access to struct array.c on the server. Oh, okay, no, that might be okay. Do you have access now? You're all very understanding. I appreciate it. Awesome. Now, someone was saying though that yesterday's code wasn't working, but it all looks like it's working to me. So I'm going to assume it's all working. Okay, go have a stretch, make a coffee. Yeah, you know my keyboard now, so you can all rest easy on that. Have a stretch, go for a walk. Kovsky, the one lecture I missed, I have no clue about. Which lecture were you talking about? Coffee machine reveal, maybe next time. And you missed the keyboard reveal. Okay, don't go for a long walk. You go for a short walk. Oh, goodness. Okay, I'll see you guys in a few minutes. Bye bye. Okay. Welcome back, everyone. Are we good to get started? Want a few more minutes? I think for the rest of the lecture, we'll be talking about 2D arrays or arrays of arrays. So, I guess get strapped in for that. Yeah, you got the playlist. It's the same one I use every week, so. Doesn't seem to get the YouTube videos pulled off YouTube, so that's good. Yeah, sounds good. You can play the play the playlist when you're having a breakdown over assignment at 2 a.m. That's not good. Okay, good to get going. No, you're going to be fine. You're going to be fine. We have the help sessions have already started this week. Has anyone seen those? Has everyone? I should have mentioned that, actually. Whoops, I don't want to show you that, but if you see on the teams, you should all have access to this COMP1511 team. There's this help sessions channel. If you click the schedule, more and more help sessions will start getting scheduled here. So you can just jump in, and if the help session's running, you can just join it nice and easily. Cool? If you can't access this team, let me know, but it should be available for everyone. Okay. Kovsky, how does one imagine that array? I guess you don't. Okay. All right. 2D arrays, or accessing an element inside an array of arrays. So if we've said that we can store anything in an array, like a struct or a data type or something like that, the next sort of logical question is, well, can we store an array as an element into an array? And then I suppose the second question is, well, why is that useful? Right? We don't want to do things just because they're cool or complicated. We want to do things because they're useful. And the reason that 2D arrays are useful usually is because they nicely represent grids. So if you think of a chessboard, for example, you could model a chessboard as a long 1D array, but if you want to naturally access the grid as a grid, right, with coordinates, you know, C2, for example, a 2D array nicely models that data structure. So there's a few different types of 2D arrays. How do you declare one? That's what this first line is doing here. You give it the type of the array. So once again, just like all arrays, it's the same data type that has to be stored. So this, for example, will be an integer of arrays, an array of integers. So each element in this array is still an integer. Doesn't matter where the element is. So just like all our arrays, it's the same data type. Typically, number of rows is the first array, number of columns is the second. That sometimes switches around. It sort of depends on how you want to structure it. So yeah, a 3x5 array, you know, is something like this. If you want to access an individual element from the array, well, what do? Well, pretty simply, you put the first lookup index and then you put the second lookup index in a repeated set of squared brackets. I actually kind of agree with you, Timmy, that typically I put columns first, but it would be up to you. It's you're the one that's deciding how to structure this. But yeah, it is up to you. Okay. Any questions on declaration and accessing here? Yeah, a 2D array is just an array of arrays. Exactly right. The first one does not have to be rows, no. It can be columns and then rows. It's whatever you decide it to be. We'll do some hands-on demos in a moment. Okay. Dorian, can you keep stacking arrays? Absolutely. You could have a 3D array, but I've never seen anything more than 2D arrays be useful. But you could do it if you wanted to. Now, we never wrote this program last week, but if you like, I think we stored the temperature as each day in the array. So you could imagine with something like a month, you know, where it's 1 week at a time, you could have something like this. 4 rows, 7 columns, for example. But really, I think a good example for an array of arrays is like a chessboard or something like that. Okay, so I think the only part that's really going to trick people up is using while loops to access 2D arrays. So typically you would have a single while loop that would loop through each element of the array, accessing each individual container. You can't just do that with a 2D array, because when you loop, you need to loop through, and then you need to have another loop that goes through every sub element in the subarray. Does that make sense? So you're always going to need 2 while loops to loop through the first array of arrays, and then when you get to each array, you need to loop through all of those elements in that array. Yeah, and you've probably seen some lab examples with some of this. So this is a really nice way of sort of representing this. So we're making an array, 3 rows, 4 columns. We start the row variable at 0. While the row variable is less than or equal to 3, we start our loop, right? So row is 0, but then we set column to 0. While the column is less than or equal to the number of the columns, we loop, and then we can just print each row column in the array, adding to the column, adding to the row. And you can sort of imagine that, these variables are increasing as the loop is running, right? So we came here, we run the first while loop. We came here, we run all of this second while loop. This ends, right? Then we increment the row. We come back here and we set the column back to 0, and we keep going. Yeah, so row column is nice because it's a way to think about it as going through each row first. But this is what I'm saying, like, it could be a case where you want to go down the columns first. You could just swap it. Why is column initialized in the while loop? Because it needs to reset. For example, here, this row gets incremented, comes back. We need to reset it back to 0 so that we can access from the first column. It's less than or equal to 3. In this case, because there is, no, that's right. It should be 2. That should be 2. This could be wrong. This could be wrong. Is that right? Tammy, Patrick? Do we all agree? Because if row is 3, this is 0, this is 1, this is 2, 3 would break. Yeah, it's wrong on the slides. Apologies, everyone. Good catch. It should just be less than 3 and less than 4. Yeah, that's right. Yeah. Daniel, is it better to make col 0 instead of initializing col 3 times? Oh, I see what you're saying. It's because you're saying it's declared 3 times. Yeah, I agree. I've brought this up in the past. One thing to keep in mind is that, yes, technically, I think you're right, but the compiler will optimize that out likely anyway, so it doesn't really matter. But yes, you could say int col equals 0 up here and then just set col here. It's not initializing it 3 times that's the problem. It's declaring it 3 or 4 times that's the problem. But good catch, everyone. I mean, it's really good that you're catching this. Yeah, so the code's a little bit off, but the idea here is correct, right? We can loop through and access it all. Okay, we already did our break. Okay, so basically for the rest of the lecture, we're just going to write a slightly bigger program than usual. We'll be putting a bit of everything in there, but it's going to be based around 2D arrays. So here's a little program spiel. We're on the hunt for ice cream. What else is new? We want to explore a certain area of Kingsford to see if we can find ice cream on a 10 by 10 grid. I want to be able to move around this section of Kingsford going either left, right, up or down. I want to explore as many places as possible. I don't want to miss an ice cream opportunity. Once I've explored the section, so once I've explored all of Kingsford, let's say, or I go to the same place more than once, it's time to go home. Okay. We're not going to have any starter code. We're going to start it from scratch. All right, and let's just get straight into it. Okay. So, gedit ice cream hunt .c ampersand. Here we go. What do we always do? Void return 0. Okay. All right. So the first thing we want to do is we want to have our sort of map of Kingsford. We can call it Kingsford, for example. We can make it an array of a 2D array of integers, so a grid of integers. We'll call it Kingsford, and it's going to be a 2D array. We need to set define the number of the columns. We'll do rows first to be 10, to be 10 as well. And then that simply gets put in here. That simply gets put in here. Okay. Now, what I'm going to do, first of all, I should also put Jake Manzella, 22T2, uses a 2D array of ints to track state. We can get 0 is unexplored, 1 is explored. We can start off as that for now. I can move around when I visit a area. It is set to 1. Okay, so the first thing, so what we're sort of saying here is that in this 2D array, each element is going to be an integer, right? It's an integer array. And we can use this shorthand like this to default set all of the values in this 2D array to 0. Right? Now, one of the first things I think we want is a procedure, so that will print the grid, okay? And it's going to need to accept the grid as a parameter. Unexplored, 0, 1 is explored. It's going to accept this grid, and then it needs to loop through each element and print it out to the terminal. Now, we sort of showed this code off in the lecture content, but we can just say int row is equal to 0, int col is equal to 0, while the row is less than the n rows, col is equal to 0, while col is less than the n cols, yep. Okay. Array is called Kingsford row col, and we should just be able to print f %d like that. I think with a space. And then we'll need to print after that ends. We need to do col plus plus. Yep. And we want to go printf a new line. Oops. All right. Let's just see how that looks. So let's call print grid. We'll pass it in Kingsford, just like that. And we should, if that all works, get out the grid. Okay, forgot my semicolon here. Really want it to stop doing that annoying thing. Okay, that works just fine. If we print that out. Okay, cool. There's a 10 by 10 grid, all initialized to 0, because that's what we did on line 30. And if we remember, 0 means the area is unexplored. That's fine. All we wanted to do here is to make sure that this rough idea of printing the grid is working just okay. Isn't that cool? Do we have any questions on what we've got so far? Why do I always compile it as program? Just because otherwise I'll keep making executables in the folder that get served. There's not really need to. It's, I don't know, it's just habit. There's no right or wrong, I guess, to it. Okay, let's do something more interesting. We want in our main, the other thing we can start doing is setting up these signatures. Yep, okay. All right, so down in main, we've set up this 2D array. We've printed out the grid. That's fine. We also want our human, our player. So we can use a struct for this. The signatures, if you remember the signatures, they allow us to change the order. So if I have the signature here, I can put main on the top, which some people like to do. If we didn't have this signature, this wouldn't work because print grid needs to be declared or defined before we call it. So that's all they do. These are function prototypes. Oops. Okay. So let's make our struct now, our player. What are we going to put in here? So it could have a character for the player's like initials, or initial, I guess. And then it probably needs a position, so int position X, int position Y, so that this player can exist somewhere on the grid. Bonrick, does the style guide want it this way or can you define it? That's a great question. Someone would need to check the style guide, or Tammy and Patrick can let us know. When do we call a function? How does the program know to go to the actual function and not the empty proto function? So it knows that a prototype is not a function declaration. So it knows that it's never going to like execute it because there is no body, right? There's no brackets. What the prototype is saying is that, hey, take my word for it, when you scan through this program, this prototype exists, this function signature exists, therefore it will be executable after the program is compiled. So we've defined our struct here. We've got some initial, that's like the player's initial, the X and the Y, right? Because if we've got an X and a Y, yeah, it's like saying just trust me, bro. Exactly. Or are you saying trust? Anyway, if we have an X and a Y, that means we can exist somewhere on this grid, right? If I have an X, do you see what I'm saying? If the player's got an X and a Y of like 1 and 1, that means that player should be able to exist on this grid. But that's just declaring the player struct, so we need to then create the player struct. Okay, we can just do that in main after we set up our array. So we can say our struct player my player. Okay. My player dot initial. Someone want to give me an initial? Nathan, you can definitely put your functions above main. That's fine. Yeah, this was a really dumb question now because I'm going to get like 80 different initials. I'm going to put, maybe because I'm egotistical, we'll put a J. We'll put a J there. J for Jake. Sorry, Nickel. Okay. Then we can do my player.x, oh no, .pos x. Right now, why don't we just set it to 0 and then, oops, the y is also equal to 0. Remember, it is just a character, so you can't do 2 letters. It has to be a single letter. That's the problem with it, I suppose. All right, and then we just set that player to be the first player. Okay, I'm just getting word that we actually do want main to be on top. I can't remember whoever asked that. But make main the first function so that you can just see what happens when the program runs. Okay, anyway, that's besides the point. So we set the x and y to 0. Now what we also want to do is that when we print our grid, we indicate on the map where the player is. So the way we can do that is by passing in my player to the print grid. We might actually want to change this to print game now because it's not just printing the grid. And it's going to also accept a struct of the player. We'll just call it my player again. That's fine. What exactly is the point of making the second struct? We haven't made a second struct. We've only got one struct, but you might want to rephrase the question. Okay, print game. Okay, now we're going to print here. So instead of just printing the value in the array, which is always going to be 0 or maybe 1, for example, we can say if, what did we call it? My player.pos x is equal to I guess that, you know what might make this easier is if I do, just to keep it consistent, I'm just thinking, we make it row and column. What do you think? That should be a bit more clearer. Because then I can just say here, if the row is equal to row and the col is equal to col. So what's this if statement saying? We can document it. If the player row col is the same as the current row col in loop, then we are at the player's position. So what do you think we want to print if we're at the player's position? And then we can just do an else. Print the actual number. Well, you're saying ones and zeros, but we could actually just print my player's initial. What did I call it? It's not just initial. Yeah, it is. And I actually need to printf it. %C, isn't it? Backslash n. No, not a backslash n. Just a space. Okay. Do we have any problems? Yes, we do. Semicolon after the struct up here. Okay, line 33, too many arguments to function call, expected a single one. That's probably because I didn't fix the function signature to include the struct as the second parameter like I did in the actual function itself. Okay, and then if we run the program, what we should see is that J is at 0, 0. Why is J at 0, 0? Because I initialized the player to start at 0, 0. Cool. But we're not going to display a 1 to show that it's explored. We're going to display the initial to show that that's where the player is currently at. Cool? Any questions so far? J is for Joe too. Good point, Joe. Yeah, once J moves, it's going to be a 1. Exactly right. Exactly right. Oh, let me just... All right. Where's main gone? I'm going to get some ice cream too. No, you should be coding along. Okay, we print the game. All right. What do we want to do now? Well, we actually want to let the player move around the screen. So to do this, we can have a while loop. And we need to be reading in some user input from the user to tell us you know, which direction they're moving. So we can store this direction. We can actually use a character to store this direction. Stores, and we can do W, A, S, or D to indicate whether they're going to move up, left, you know, up, down, left, right, for example. Now, if we're going to store a character, then we need to scan in a character. So scanf, remember when we're scanning in a character, we put a space before it to character escape it. and we're going to store that in our direction variable. Now, if anyone astutely remembers, scanf returns the number of things that it was able to scan in. So what we can do to keep looping is just to say while scanf worked, so while it scanned in one thing, we can just keep going. If it didn't scan one thing in, then it didn't work. We don't want to keep continue because we don't know what's going to happen. So we can actually just put scanf directly in the while loop. In fact, it's something that you'll want to do in your assignment. You might want to do. Now, you don't necessarily have to do this. You could have the scanf in the body and then have like a variable that stores the result, but this is just a little bit nicer. So while scanf read one thing in is basically what this line is saying. We can keep looping. Now we've stored in the direction, and if we're going to do this, we need a printf. Enter WASD to move around like that. Okay. Okay. Now, the first thing we want to do after entering a direction, or even before we actually make the move, is to say that the player's current position, oops, what have I just done? Is now going to be assigned 1. So this is how we're going to keep track of the fact that the player might be moving around. All right. Now we need to look at what the player entered. So if the direction is equal to W, what was that? Let me just get this all set up. Okay, W, A, S, D. If player moving up, what's that? Left, down, and right. So Reen says, but if the user enters something other than one value, wouldn't there be no way of reprompting to user to enter a valid input? That's correct. This program would just sort of give up. But we don't need to really worry about it. If the user enters, we're not really dealing with validation and prompting the user again. Bonrick, it should probably recognize the position of J will become 1 now. Well, even if the position of J is a 1, it will still just, it's only going to print the J. It's not going to print the 1. So that's okay. What does line 41 do? It's setting the player's position to 1 so that we know that the player visited that grid. Depending on how long I've got left when I get to the end, we can look at ways of making this nicely. Okay, so if the player's moving up, what do we need to do? Well, my player, now let's think about it. If we got this grid and let's say the player's here and we're moving up, what are we going to be changing? Well, it's not the column's not changing, the row's changing and the row's going lower, right? Because this is row 0, 1, 2, 3, 4. So my player dot the pos row is going to be minus minus. We're going to take one off it. I mean, that's pretty straightforward. That's up. S is down, so we'll do that next. That's just going to be a plus plus. Oops. Now, let me copy this again. A is left. That's going to be the column. If we're going left, we're going to be going down, so that's just fine. And then D is the column going right, and that's going to increment. I can see a lot of things in chat. Okay, someone asked, what if the player tries moving out of grid? Excellent question. We're going to have to fix that. Why don't we just give this a go though? Now, this is going to happen in the grid, so that means we want to print every time. Actually, we don't need a \n there. We can just do that. But we want to print the game every time the loop runs. All right, let's try this. Are we going to have compiler errors? Oh, no, we aren't. Spam pog. All right, enter WASD to move it around. Well, we can't see the grid, but let's just move down. Okay. I mean, you can sort of see that's already working. Enter WASD to move around. If I move right, there we go. I visited here. Now my player's here. I could go down. I could go down again. I could go down again. I can go up, down, up, down. It's kind of doesn't care that I'm revisiting. What happens if I go left again? What do we think is going to happen here? Is this lecture code available? It is now. What do we think is going to happen when I go left? It's going to break. Let's find out. It's gone. The program crashed. You're using an illegal array index of -1. Valid indices are from 10, 0 to 9. Make sure the size of your array is correct. That's pretty cool. I mean, that makes sense. So what that means is... Ooh, I gotta stop doing that. After the player moves, we want to make sure that that was a valid move. Why did it take a while? I don't know. Maybe it was just taking some time, or it was probably waiting for the scan to go through or something like that. Okay, so we do need to work on this. So if my player dot pos of row is less than 0, or my player dot pos of row is greater than, it should be n rows, or is it greater than or equal to? I think it's greater than or equal to, because that's the number of rows. You can't be at the number, that number of rows. Then what we can do is just, oh, actually, can we do it like this? Because we can't reset it. So let's not actually do it like this. So if we go, so rows are like this, so we've gone above the top, we can just hard set it to be 0. If the rows is greater than or equal to n rows, we can just set it to be, and that should be a single assignment set. I'm sure someone's spamming that in the chat right now. Good catch. Yep. That's really annoying. If the position column is equal to n cols, we can set that to n cols, and that needs to be the column. And then I guess these should be like this. if the column, oh no, that should be less than 0, then it's going to be equal to 0. And then close that off there. Okay, Nicholas has asked a good question. Normally W is for up and S is for down, but the functions are operating in opposite directions. That's not the case, right? When we're going up, W is up, but we're going a lower column number because the 0th column is at the top. Does that make sense? So it is work. I am pressing, like I'll show you. In fact, I should definitely print the game here. Okay, so if I go, I'm pressing down, I'm pressing S and it's going down. I press D and it goes right. If I press left again, it goes back. If I press left again, see it's staying there now. It's not moving me off. Oh, something went wrong with S. Something went wrong with going down. So when the row was going too high, when the row is greater than or equal to the number of rows. Oh, okay. Has anyone covered or found what's going wrong here? Yeah, exactly right. Exactly right. Oop, clear. Recompile it. Always off by 1. I read a paper once that said off by 1 errors is the most common introductory computing student error. I don't know if that's true, but all right, let's see. Can I go off the top? No, I can't. Can I go off the bottom? No, I can't. Can I go off the edge? No, I can't. I mean, cool. This is already sort of a nice little... Oh, that's trippy. Coordinate 0, 0 is at the top left. Yep, that's exactly right. Thanks, Tommy. Cool. Big snake ape, that would be cool. All right, so a few more things we can do here really quickly. I mean, this is already sort of a decent place to leave it. We could say that if the player visits a square they've already entered, then we've got a problem. So we could do that simply here. In fact, we should make a function for this. Check a revisit. So we need this as well. And we're actually going to just return Kingsford, that's our array, and we're going to use my player dot row dot pos row and the col. So if the position of the player in the grid is equal to a 1, that means the player's already revisited it, Kingsford. And that's going to return true. Otherwise, it will return false, which means over here we can say if check revisit Kingsford my player. If that's true, we can just do something like a return 1 to end the game. We can come up with nicer ways to do that in the future. Then we just need to declare this. prototype. Okay, what have I done wrong here? If check visit should be like this. Okay, line 21. Oh, I didn't give it the return type. It should be an integer. Did I have it down here? Yeah, I did. That's fine. Okay, now what should happen if I go left right now, it should end, which is exactly what's happened. This is a cool program, but I'm confused because there's a lot going on. I mean, that's completely sort of reasonable. There is a lot going on. This is sort of, but I think it's, if we keep writing small programs, we'll never get out of our comfort zone. But the idea is to sort of break it down and look at the individual functions. If you can look at individual functions and understand it, then it might take you like time, but you will understand the entire program. That's exactly right, Daniel. I think the number one thing that overwhelms us when we look at large programs comes from the fact that we aren't the ones that write the program. If you write a program of this size, you will understand where everything is and what everything does. When you just read a program of this size and larger, it'll be really easy to get overwhelmed. What's most important is to sort of slow down, look at the functions, read the functions, look at the data structures. That might be a good first place to start here. Our data structure being the array, or the 2D array. Do you understand that part? Look at the printing procedure. Can you understand this part? But the number one thing is just not to get overwhelmed. You need to go through it step by step. Exactly right, Matthew. So Magwita, is there a way we can print characters rather than numbers? Absolutely. You could make it an array of characters. And then you'd have to refactor the program to work that way. But you could absolutely do that. How do we access this code again? Someone will post a link in a moment, I'm sure. But I mean, this program's got a lot of stuff. Here's a bit of a hint, nudge, nudge. A lot of stuff that you might need for assignment 1. We've got scanning in a loop, using a 2-dimensional array, storing things in a 2-dimensional array, and passing it around. So we'll get the link to the lecture code. There it is. Thank you, Patrick. In a second. This is pretty good. What could we do from here? We are out of time. There was one fun thing I was thinking of doing. Maybe if you want to head off, you can head off. You can do that. Matthew, can you explain the scanning in a loop? No problem. That's happening right here. Scanf returns the number of things it read in. We want one thing to be read in, therefore we can check, did scanf read one thing? If scanf read one thing, we run the body of the loop and we come back and we scan again. If it did not read one thing, we don't continue scanning. Jay Huang says, how come when you call a function with an array, you don't need to include the pair of brackets? So you're talking about something like here, where we pass the array in to a function. Why don't we have to, put the brackets here? And that's simply because when we have the array itself, the brackets, look up the element of the array. So this would pass like a single element to the array. We just want to pass the whole array. It's the definition that needs to know how big, what the structure of the array is. Timmy says, am I able to go to help sessions only to ask about the feedback on my style rather than the content itself? I don't see any issues with that. Cool. Crying time, yep. Can we have our functions at the top of the code instead of below? We want main at the top. As long as main is at the top, then the rest of the order doesn't matter. But main needs to be the top below the prototypes. What was the fun thing? What is the check for revisit again? We could look at that. The revisit's, I mean, it looks oddly short, right, for what it's doing. But it's pretty much saying, right, go to your 2D array, which is here. Look up the player's position. No, whoops. Look up the player's position in the array. So like here. If that value in the grid is 1, which means it's revisited, it's already been visited, right? Then we return true, true being 1. So if that's true, if the player's already visited the position, we exit. We return to exit because the game has ended. Yeah, we could have a return 0 here. It doesn't really matter. It's a good point, actually. Because there's not actually been an error. It's just that the game's over. So this will return out of the loop, which then will exit the game. So the program would have returned to 0 here. That's fine. It doesn't actually matter what number this is. In fact, that could just be return like that. Never mind. No, that is returning from main. So, but it can be a 0 because it's not an error. That's fine. Yeah, sorry, it returned to main. Yeah. I confused myself. How are we making the ones? Pretty simply, we're doing that right here. When the loop runs, we take the player's position and we set that element in the array to be 1. So that's happening here on line 41. Put some more comments here. Set the player's position to 1. Yeah, I think you need to hit enter because it's scanf Matthew Young. Yeah, good point. Okay, that's the end of the lecture. Oh, before you go, feedback as always, much appreciated. I know the programs and the lectures are getting a little bit more complicated now. So it's important for us that we're getting the feedback. But, you know, that's the joys of programming. There's always more to learn. There's always something more complicated. We can do the fun thing. We'll do the fun thing after the feedback, but it's optional. So if you need to go, you can feel free to head off. So Matthew, keep in mind, so I'll give this a second here, and then I'll keep talking. Yeah, I'll do the fun thing now. Okay, feedback form's gone through. That's probably enough time. All right, so once again, this is optional. So if you want to head off, feel free to head off. It's nothing even useful to COMP1511. It's just something cool that we can do. So if you remember, we always set up the player to be at 0, 0. So what we can actually do here is write a function that can return the player, that initializes the player. It doesn't accept any parameters. We can copy this code in. So this sets up the player struct itself, and then it can return my player. Now, that's not particularly cool, but it's a bit boring that the player always starts at 0, 0, don't you think? So it'd be cool if it was maybe random every time the program ran. So the way we can do that is by using some of the built-in random functionality that exists within C. You might not have seen anything like this before, but that's okay. And like I said, it's not really useful in the course. I don't think you'll need to use it anywhere itself. There's a few things you need to do. Whenever you're doing anything with random values in a programming environment, you need to initialize the seed. So seed random in this case. A common way to do the seed is just to pass in the current timestamp to the seed function. You do not need to understand how this works. Don't stress about it. It's just for fun, right? So we can set this in like that. And I'll just give it a comment. Seeds the random function. If you want to read up about how seeds work and all of that, you can feel free to do that. Then instead of being at 0, we can call random and cap it to n rows. And we can do the same thing for the n cols. Generates a random integer and caps it at the max value. This isn't a perfect, like, crypto grade random number generator, but it's good enough for what we're doing. Now, these, who just said that? AR11, aren't these in a library? Absolutely right. We need to import time.h and include stdlib.h to get access to these functions. And that's it. The only thing we then need to do is make sure we call this here when we create the player in main. Okay, fantastic. Oops, that doesn't need to be there. There we go. No errors, very nice. Let's run the program. And there we go. Jay's over here now. Let's quit the program. Clear that. Run it again. I didn't compile it. I just ran it again. And now it's over here. It's crashing because it's like, you're not scanning in, right, Jake? Now I'm down here. Pretty cool. You can sort of see, right, like how little bits, little things like this is how like you start making, things like games or things like bigger programs. It's just really small incremental changes. What does library mean? These are all libraries. So libraries are just pieces of useful code that other people have written that are available to you. Yeah, it's like a library of functions. Yeah, exactly. Okay. Happy to leave it there. There's some more stuff we could do with this program, I'm sure. Yeah, you can absolutely make your own library. I don't know if we cover it in much detail in this course, but it's something that you'll definitely be needing to do. Okay, I'm sure I feel better. Thank you, though. Thank you all for hanging around a few minutes after the lecture ended. How do you make a library? I don't know if we're going to have time to cover library creation in this course, but you'll definitely learn at some point in your studies at UNSW, no problem at all. Thank you all so much for being coming along to the lecture. I hope you learnt a lot. Fill the feedback in as usual. Good luck with assignment 1. Go use the help sessions. Look after yourselves. Be kind. Have fun. I'll see you next week. Thank you, everyone.